Good evening. I know you're all tired. I'll try to be concise and convey information briefly. And then we talk about how can we use data visualization in while during the pitching. If you have some idea and if you want to persuade someone that they have to do something, for example, or if you want to just influence somebody by using data visualization, I will just show you a brief example what I have done during Democracy Summit in Copenhagen this summer. And then we'll have some activity. We will use several data sets, and you can visualize data, and then we can try to convert what you will make into some kind of pitching phrases or something that you might find useful. So there is no such a thing as like dedicated fields for how you should use data visualization for pitching. So I'm just using my example. I will try to explain everything that what we have done and what I have done during the summit. So in the beginning, let's define what each of those terms mean. Pitching is when you're trying to persuade someone to do something, and data visualization very briefly means that you represent some kind of information, whether it is a quantitative or qualitative, into in a graphical way, in graphical formats. So let's begin by this very minimalistic visualization. What do you think this visualization represents? I'm pretty sure some of you might have seen this already. Do you have any versions what this might be? Looks like Netflix intro. No, this is more than 100 years average temperature, global temperature. You said that? Okay, good job. So now we know what it represents. What do you think? What's the main point on this visualization? Like when you look at this visualization? Yes, global warming. Yes, but very abruptly. Yes, we have almost like an average, some kind of plus or minus something. I don't know what's the margin number here, but anyway, we see that more than 100 years we have similar temperature, and when we come to the present from the 90s and after the 2000s, then we have a very high temperature. So this is actually represents deviation from the average temperature. So we see that and it has an effect. When I think it was made, this is called global temperature stripes, because you can see that those are stripes. And I think it's the cover of maybe Time magazine or something. But it was very effective, and it became very popular because it conveyed the information easily and very simply and in a very understandable manner. So you see that the journalist during the TV program is using that visualization to talk about global warming. And on the right side, it's more. It is taken from the actual paper, academic paper. So you see that is a bit different. It is not as fancy and beautiful as it is on the left side, because depending on the audience to whom you're pitching or who is your audience, in general, you change how you represent your visualization. If your audience is academic people, they just want to know what you want to say. They do not care about how beautiful it is. It should be very simple and understandable. But if you want to talk to general audiences, you have to have some kind of catching some elements in your visualization. So that's why those stripes are very effective. Hold on. So in 2020 or 21, we teamed up with Indigo magazine, which is Georgian pre-intent web-based magazine, and we try to understand during the pandemic what kind of effect the pandemic had on the social life in Georgia, how it affected society in general. So we took we try to gather as many open data as possible, and then look into different areas of social life, and we try to see how, for example, patterns of behavior changed during the pandemic. And then we wrote a report, which is still going to be published during these days. So we took a lot of, we made a lot of visualizations, more than 20. We began by describing, for those who don't understand Georgian, this is which I just made in Georgian, so I can briefly explain each of them. So this is just excessive deaths during the pandemic. That shows you how many people died during a specific month, and whether it is more or less to the average, like a decade average or something. So it shows that on the right side there was a excessive death, which is explained by pandemic. So then we checked this databases. We took this database from Oxford University. They set up this data collection program. They collected data from all over the world, how the governments reacted to the pandemic, what kind of regulations they had, how they imposed those regulations, and so on. So it's just sort of like it shows you how governments reacted to the pandemic. So we have on the upper left side, we have how strict the government was during any day during the pandemic. So you see, if you remember the story in Georgia, it was everything happens abruptly, very soon, very quick in Georgia. We had lots of restrictions in the beginning, and then we loosened those restrictions, even though the cases of the COVID went up. So this is a very detailed visualization. You can see in which area of social life, what kind of regulations were imposed during which periods. We also took Facebook data. They have this data for good program. You know, this big companies, most of the time they have this social direction. They have this data for good program. They release some parts of their data to be accessible for the public. So if you're a researcher, you can take those data. You can analyze and visualize those data. So this is how whether people stayed or left home during any specific day during the pandemic. And this is on the level of municipalities in Georgia. Municipality, for those of you who don't know, in Georgia is like administrative entity, which is smaller than the region. So what this shows is that you see there's a pattern in the movement of people, like whether they stayed at home or not. Of course, it's very obvious why that happens. It's because governments imposes some restriction on public transport, on vehicles, closes the workspace, schools, and so on. So their pattern of movement is dependent on the regulations. But also you can see how those municipalities differ from each other. Some people in the municipalities stayed at home more often. In other municipalities, people stayed at home or didn't stay at home most of the time. So you can see how people react to that regulation in different municipalities. And we also did this correlation analysis, which kind of restriction is, what kind of regulation is correlated with the movement of the people. Like, for example, if you restrict the movement of the vehicles, is that the biggest correlate of staying at home, or is it something else, like closing schools or closing universities and so on? Then our colleague Georgi did those map visualizations, geographic visualizations. This particular one shows where the middle-sized businesses are concentrated, which shows that they are concentrated most of the time around metro stations. So if you impose restrictions on public transport, you sort of disrupt this business. People who are the owners of those businesses, they do not have income. People also who use public transport to consume something or to get the services, also they can't do that as well. Also, we can see that there's a economic disparity between people who live in different parts of Tbilisi. You can see this one shows how often people use from specific area. How often do they use public transport, or how often do they use just their own vehicles? And you see there's a huge distinction between people who live on the left side of Tqvari and who live on the right side of the river. So if you have a restriction on public transport, so that means that some people have privilege to get to their work, some people cannot go to wherever they want to go. That is also true in what kind of area people work. If you have office work and if you close down the workspaces, people who work at office, they can work from home. They can go online, do their work online, and they still can retain their income. So it might not be as huge problem there, rather than for the people who has manual work. So if you work manually, if you have to be at some kind of somewhere, you lose your job. You don't have an income. So that's also pandemic in that sense, and regulations create that disparity between the people. There was a very good research that used Facebook's, it is called Social Connectedness Index, which means, in a very simple way, means how many Facebook friendship is between two regions. In the US, it was between the counties, and in Georgia, it was between regions, not municipalities, but regions. But there was a very interesting correlation when they did the analysis, not in case of Georgia, but in the US. They found out that if there's an outbreak somewhere, for example, in New York, there's a higher chance that the pandemic, those outbreak will spread to the region where there's a higher Facebook connection, this higher connectedness, social connectedness index. So we had that idea, maybe we can also find some correlation in Georgia as well. So if there are some high connection between regions, maybe and there is a outbreak of COVID in that area, maybe you have to expect that it will spread into the relevant region. So this shows what you see, those curved lines. Those shows, and the thickness of the line actually tells you how connected those regions are with each other. And some regions are connected to each other more than the rest of the regions. But we didn't find that correlation. The spread of the COVID and this kind of connections wasn't correlated in our case, at least visually. We didn't do statistical analysis. So this is also a very good data, which shows, which records every conflicting event that happens in Georgia, and also in many countries, but also in Georgia. So we took protesting rallies, and we saw how pandemic disrupted people's behavior in terms of protesting something, which is almost like a daily job in Georgia. So you see that in the middle, which represents the period where the government imposed regulations. We see that there's almost no protesting rallies happening in Georgia. And then it also comes back as business as usual. Also, this research was done by CRRC. They scraped the data from a Telegram channel which people use for drug sales. You can order drugs from that channel, and also, so he did lots of work behind this. But he gathered data about what kind of drugs are being sold, what is the amount being sold, and so on. So you can see that those are the types of drugs, for example, cocaine or MDMA and so on. So you can see that restrictions probably cut the supply chain somewhere for some kind of drugs rather than the others. For example, you see that after April, opiates almost disappear from the picture, which means probably there was some kind of restriction about that chain. So what we did, so we had this is a separate project that we did with Indigo. So then I had to go to Democracy Summit, and I chose this project, and my main message was for the governments in the first place, that you can use this kind of open data, and you do not have to spend a lot of money to use this data and to make better decisions, especially regarding social issues, decisions, policy making, and so on. So what we already had done, I tried to pitch those visualizations to the audience. So the main idea was that governments have to make decisions. It's a very difficult process because you have to understand reality, and reality is complex and so on. So they have lack of knowledge, skills, and willingness. And when the government cannot represent, when government doesn't make efficient decisions, this means that many people who have problems, they are not represented in their decision making. So the idea behind this pitch is that we were trying to tell government that they should do that. So, but I meant to got a backslap for that, and so that is what our organization is doing in a way. So we also try to pitch for ourselves, like this is what we do, because we were there for the reason. We have many directions. We make these social projects. We also have our commercial side. We can provide the services, for money. We also collaborate and so on. So we were also trying to tell the audience, Georgian as well as those people who were there, that we are this kind of people and we can do this and that. So we talked about, I explained what this visualization about the movement of the people represented in our visualizations. I just described it. But when you're pitching, just description isn't enough. You have to summarize and you have to pinpoint what's the most important message in your visualization. So instead of saying that we see that there are differences between the movement of these municipalities, instead you can ask the question, if you have crisis, for example, how can you track the people? If you have the regulation that's which purpose is to follow and track people where they go, whether they stay at home or they leave home. How do you do that? You have to do that actually. For example, this data was used by Poland when the war outbreak was in Ukraine in February. They used this daily data. People, where was the increase of migration near the border of Poland? So they could provide the services specifically to those areas rather than just had general idea that people are coming and we should provide some kind of services everywhere equally, which wouldn't be very efficient. So you can ask questions like, how can we track people if there's a crisis? How can we do this? And you can say that then this visualization helps me to answer those questions. I can use this data. For example, I can see that in some municipalities, people, I don't know, take one. Akhmetov, which is a municipality in Kakheti, eastern side of Georgia, they people more or less stayed at home. But in Marneoli, which is southern part of Georgia, where people that consist mostly of ethnic Azerbaijani people, they do not understand. They have a language barrier, so which shows that those people had difficulty understanding what government was asking from them. So they did not comply with the regulations, and they moved a lot. If you remember that period, also it was in the news. There was the problem there. There was conflict because of that. So you can say that, yes, we have to use this kind of data and visualization to answer those questions. In this case, yes, we didn't find any correlation between those variables. But you can ask a question like, if you're in a certain area in your country, and you know that there was in adjacent region somewhere there was an outbreak of COVID, should you be worried that should you stay in that area where you are right now, or should you move around to go somewhere else so that you reduce the probability that you might contract a virus or something? So you can answer that question as well. And that just shows, so this is our team, what we do. We want to collaborate with the governments, maybe, and media organizations too. So what you can do is that when you say this, you can say that we can do this kind of analysis, but we're also open to collaborate with the governments or some other organizations. So we can collaborate with the media, so we can push the government to do something about those issues. And that we are also trying to develop an package that might help us. Okay, that's how I try to translate that those visualizations into pitching. So we had around 2 minutes or 3 minutes. Do you remember how long this was? 2 minutes, 5 minutes. You sure? 3 minutes. It was 3 minutes. You cannot say. So we made around 20 visualizations, more than 20 visualizations. You cannot fit in more than 20 visualizations into 3 minutes. So we just picked and choose some of them, and then I just verbally described some other visualizations. And that was it. That was the pitching part of it. I don't know how understandable it is. What's the difference between the pitching part of the same visualizations and just description of those visualizations? And if you have questions, before we go to the practical session, we can do some data visualization. Before that, we can talk about it a bit more if you have questions. Do we have to? That was quick.
So I guess I will have 2 questions, and that's good that you come back to this slide because I already forget about it. First, let's start with that one. What do you mean under this conflict? Is it like the private, when there is conflict between 2 persons and there happens crime, or just like the people are protesting and demanding something from government. And second one is related with connection you were talking about, and as I probably remember, you mentioned that it's connection with Facebook. Do you mean that just having friends on Facebook, or actively interacting with them, like commenting something on their pages, or like liking their posts, or what was where bits you were looking at?
They have they actually, behind this visualization in the actual data sets, they collect all kind of information that is related to conflicts, not one-on-one, but more related to the group of people. We used only, as I remember, we used only peaceful protesting rallies. So when people come out to the streets, where there's no casualty, there's no big clash between some other groups, police or the protesters. This is that kind of information. About the Facebook, they have a very specific methodology, statistical methods, how to convert Facebook connections to actual to that index, social connectedness index. What was it? This one. So they take a base number. Floor number is 300. So you have to have 300 people at least who has turned on the location service on the mobile phone, so you can track the people. So they have divided the whole globe into 600 by 600 square meter tiles. So if you cross the tile during the day, they know that you have crossed that tile. And 600 square meter, sorry. You can suppose that might mean that you're just leaving your home and you're going somewhere else. That's how they translate that. What was? Did you have another question? Okay.
Hi, I have a question regarding inclusivity of Facebook data. Like, how good does it capture data about lower income families, because they wouldn't have that much access to smartphones or the Facebook at all? And how was it like figured then into data?
Yes, that's a good question. As I remember, Facebook doesn't differentiate between the age groups in this data set. Not any kind of groups. They just know their users, and they collect data about the general users. They do not give you information what kind of devices or whether there's any metadata connected to that individual. But they won't give you that information because you have to stay anonymous. You have to anonymize the data. So they introduce some randomness into the data, actually, by the statistical algorithms. So you cannot pinpoint, in some cases, specific people somewhere. Maybe some political party or somebody wants to use the data. So they introduce randomness into those data.
I want to clarify. So my question was more about like lower income people won't have access to technology. Like, wouldn't it change this data? Like how people move within the country that Facebook tracks? My question was more about that.
If they had money, or do you mean like if they had technology to use it?
Data inclusive. I asked this question because lower income human won't have smartphone or computer or then Facebook. So then for the Facebook to gather data. So how does Facebook include that data? Is there any general rule, or how did you track? Because if we use just Facebook data, we can guess that it only tracks people from middle to upper income levels, not lower income people. So that's quite interesting to me.
Yes, what I've read the paper that describes the methodology. They do not differentiate between those groups. They just say that they take the data from the users. That's all they say. I don't think they make additional analysis of different groups. I don't think so. Maybe just they randomly take 300 people, 300 users. I don't know. I think if you have 300 people, it is more or less representative of the region. I think so. Of course, if you take very detailed if you increase so if you be very scientific, and if you want to anyone who lives in that region to have the similar probability that they would fit into that group, to the data to be gathered from them, of course, that would be the ideal situation. And so if you do not have that, that's not very scientific. Okay, anyway, I think it would represent, if you have 300 people in a day, it might represent a region, especially those regions who have very small population, like Zemosvaneti, Samgril, Zemosvaneti. What else?
Thanks.
Maybe we can speak about what's the difference between just making visualization and then using those for the pitching, if you want to. You know. So, like for example, I didn't show this particular visualization during this Copenhagen summit, but I also mentioned it. You can, for example, you can frame it into this question: if you have this crisis, if you have, for example, pandemic, and you impose restrictions, you do not have protesting rallies for a few days or at some period of time. But as you see, very soon, even you have those restrictions at place, people regain the energy to go out to the streets and protest whatever they want, just as they did before the pandemic. So that is already good information. Like, does it matter that we have restrictions? Can you impose restrictions and keep people at home? And even that's a very good political question. If you're a politician, can you make people stay at home? Like, if you want to suppress people. I don't think so.
You did it by yourself, and so that was my question. So, do they use this such kind of statistics?
I'm very suspicious they use it. Actually, so what's the problem in Georgia? You know that when we don't have good communication with each other generally, so often happens so that you do something, you think you're the one who's done it, and you find that later that somebody else has already done it. But I don't think they use this data because it's a bit. You have to be a bit nerd to find that that kind of data exists in the first place. Then you have to know how to use it and what to do with that data. Politicians, for good for us, they do not. I don't think they use it.
And why have you analyzed this? And so it was just for your interest, or?
So the general question in this project was how the pandemic changed the patterns of behavior in society. Protesting rally is very important part of social life in Georgia. So how the pandemic affected those in that area was interesting, and we saw that. That's interesting. I mean, I didn't expect this result. That's during autumn, it go back to almost like on the same level, maybe even more, very quickly, like after the August. But in this case, you cannot say anything very firmly because you have seasonality, you have cycles, and if you do not have data for many years, you do not know the effect is because of the COVID or because of there's some kind of pattern because of the seasons. We have just 3 years, not even 3 years. This is not enough to make firm conclusions. This is how protesting rallies work in Georgia. But this data set is very good. This is open. You just have to ask the data from the website and explain why you want to use it, and that they will give you the data, and you can see who are the organizers of this protesting rallies, whether police was involved, what kind of political parties were involved, whether they were casualties, what was the main idea of the protests. And we found out that most of the protesting rallies are about workplace. So mostly it is about working class people, or people who work manually, but those people are not, we do not talk about that a lot. That is also interesting insights from this data set. Okay, if you have any questions, we can continue to talk, or otherwise we can start a very short activity. Sorry. So what we can do, you can, if you have laptops, you can go to the website, and I also uploaded several data sets on Google Drive. I shared it with you, and you can, I don't think so. I don't think mobile phones, I don't think you can open the website from mobile phones. If you want, whoever wants to participate, this is that activity. We go to the websites. This is called rowgraphs.io. Then I have short URL for the data that I have uploaded. So this is also if you want to make quick visualizations very easily. This is a really good way to do it. This rowgraphs is just a website. You upload the data, and it shows you and guides you with what kind of visualization is best suits that kind of data. Oh, actually, I have included 2 more data sets than is represented here. So this data, one data is taken from the research that was done, international research that was done in Georgia. It's measured the attitudes of people towards different groups in our society. It's embedded in some kind of theory. We do not have to talk about it. The other one is just for fun. It's a UFO database that's actually it's a huge database that dates back from 1950s. US government actually recorded the reports of UFO sightings. When people called some kind of institution, I don't know which one it was, and they recorded that they had seen some kind of objects in the sky. And you have many good variables there to analyze visually. And also I included 1992 average monthly temperature of Tbilisi. And the fourth one is something. When you open it up, I can check it. I got it. Oh, okay. So we have that processing data set that I showed you the visualization of. Once you go to just tell me so I can also switch to the website. Okay, so the idea of this activity is that if you create some kind of visualization now using that data, how can you convert whatever you spot in that visualization to some kind of pitching phrase or something similar? Just to check and practice if we can transform our visualizations to pitching in pitching formats. Check this website. So this is the website. Did you get here already? Nope. Yes. Just hold on a second. That you have to click. That is the data sets for the link. What you're looking at? No. Mm-hmm. Once you get to rowgraphs main page, there should be a button starts now or something similar. So we have 4 data sets. You can work together if you want to. You can choose any data that you want. You can try several of them. So you have to either copy the data by copy pasting or just download the data, and then you have to upload the data into that website. Use it now. You have to click use it now on the upper right corner. The internet is slow, but I hope it will work for data visualization. Okay, so you have several options. You can either open that Google Drive folder and open the document itself and select the data, copy and paste it into the rowgraph relevance box here. Or you can download the data, then you have to upload it here from browse. You can also drag and drop the file. Let's see. Okay, I'll just to showcase, I will use this process data. So once you upload the data, or if you copy it, it automatically assigns what kind of variable you have in the columns. We have three types of data, three types of columns. It either can be a number, a date, or a string. Number is like numerical column. Also, date is if you have so people represent dates in different formats. So you have to understand which one is used in the original data, so you can transform the data into relevant formats. We cannot convert this one. So do not, if you use this conflict data, do not try to change this column into dates column. That won't be successful. But we can use this year as a factor. That's not a problem. I'll just show you how we can do something, visualize data on this website, and then you can choose any kind of data that you want to, and do visualization. Sorry. Oh, really? Oh, thank you. Hold on. Okay. Now you do. So once you have this data, we have to skip this one out. We don't want to do anything there. So then comes what kind of chart you should use. So why is this important? Ketim, why this is important? We were talking about this. So the step where you have to choose what kind of chart you have to use. As we see, we have different kinds of columns, different kinds of variables. We have a numerical variable, which is here, denoted by hashtag. We also have string variable, which is about text columns. And also we have dates. No, we do not have dates, but we can have dates. But anyway, we do not have it here. We can use year as a factor. It's not a problem. So, but we also have many categorical variables. No, we don't have a map. Not here, but in other software, in Tableau or in some other software, you can use this data set to visualize data on a map. If you have longitude and latitude, you can build a map. So once you try different charts, for example, let's see. Okay, let's take tree map. When you go to the upper left side, it shows you the information why this kind of charts might be useful for your data. You can read this. If you think that it doesn't fit your data well, you can choose another one and so on. So let's take a tree map, and then it shows you what kind of variables you have to make this kind of visualization chart. Hierarchy means that you have to have nested data, which means you have, for example, you have US states and you have cities inside the states. That is called hierarchical data. And what this tree map does is it uses different chunks for different categories, so they're nested into each other. So let's say we can take, I don't know, let's see what we can take here. We can take event type, for example, what kind of events it is. And for size, we can use just a second. Wait out, let me see. We want some numbers. Okay, so I don't know what this interaction actually represents, but let's just use it for to see how it works. Now let's take interaction and drop it into this size. So look at this small logo on the left side. It shows you what kind of variable you have to use in this area. Otherwise, it won't work. So once you start to add the variables and columns, it will start to build the charts on the bottom. Okay, maybe even type is not very good, and we can use subtype as well. Or maybe we can use region. Let's see. To change the data. What do you mean, sorry?
This numerical, there's not less rich for the dark, there's categorical, there's for string is
Sometimes it does. Okay, so this website offers some kind of aggregation analysis if you want to aggregate the data, to sum the data, to count the data, to count the average, and so on.
Are we limited in data size, or what is a normal?
On this website. On this website, you are limited. This is just a very, very basic.
What is the normal size of the data we should use?
It depends on the capabilities of your hardware. Sorry?
Do we have any restrictions?
Yes, you have restrictions. You have infrastructure restrictions in the first place. That's the most important one. If you have, for example, 30 gigabytes of data, and you have to analyze it, it's a big. You need a really powerful computer. Sorry? Minimum. There's no such thing. Depends. Depends what you want. Okay, we have to use the microphone, correct? Okay, but just a second. To continue what we're doing, if you can use, just choose any kind of data that you want, either attitudes towards group, or the UFO, or conflict, or the fourth one. Then try to build the visualization and try to see something in your data from the charts. Can you do that? Can you follow that instruction? Sorry? Okay, let's no, we can, those are all, every data set is enough to make a chart. Are you asking that? Not here. Then you have to save this, and you can make a larger visualization if you want to do that. I can also show you that. Sorry, where's the microphone? And also, if you need some help, I can come and help you.
Okay, can you hear? If we make a dashboard, website, do we have any restrictions about how we get a data and charts? If we can use some API, or like some already how can I say? So if you can use API for
yes, you can. If you want to update data in a live, if you want to be updated in live, you have to have a specific code that takes the data that is run automatically.
But so we can do that, yeah?
Yeah, sure, you can do that.
Okay.
Okay, let me show you a more simple example. I will use the other data set. Does anyone need help? Okay. Let's use. Okay, so we have different groups in Georgia, and this shows what score people give to a specific group on different dimensions. Like, for example, competence of the group, or how much warmth people feel towards this group in Georgia. So we have just a single group variable, categorical variable, and we have numeric variables, a lot of them, by the way. So we can build the charts very easily. For example, let's try again the stream map. Well, in hierarchy, we can choose group, like which group does each box represents. For size, you can take any of the variables. Let's say pity, how much pity people feel towards those people. For color, you can choose again. So you know that in charts you can include many variables by different elements of the chart. So you have usually you have two dimensions on a chart. You have X and Y on Cartesian charts. But also, if you introduce shape, for example, if you introduce color and size, you can represent more than 2 dimensions. You can have 5 variables on a single chart. So if we have size, you can see that we have different boxes for different groups of people. Let's make it more understandable. Okay, so we have labels, which box represents which group. And for size, we took pity, which means that the larger the box, more pity people feel towards that group in Georgia. And you can then color those, also color. For example, if you want to understand how envious people are toward those groups, the same groups, we can represent it by color. So we have this. Then we can come down and change the color. So it's, yeah, so the lighter color represents that people feel less admiration towards the people. And the darker the blue becomes, they admire those people more. So that is what it represents. I won't go into details of this website. You can tweak many parameters of the chart if you want. So you can decide if you want to show legend or not. You can include the legends. In this example, it shows what hue of blue represents what value on your chart. So this is 4 points. The maximum is five score, and there's a on the lower end it's 0. So we have these colors between minimum and the maximum values in our data. Yeah, let's be here. You can change color. So if you can make something this very simple, you can see if there is something very obvious in your data from the charts. And once you see that, then you can convert that description to some kind of pitching question or phrase. For example, I don't know. We also have, we took what we'll take, PT. So, for example, if we take contempt, let's remove this one, color, and take contempt. Who are most hated groups in Georgia, according to this research? Let me, if you can arrange the boxes. No, okay. Let's export and save it so we can take a better look at it. So when you want to export chart from here, you have several options. I suggest you should always, if you want to refine your charts in Illustrator or some other graphical software, you have to export it into SVG, because SVG saves specific elements on your chart, and you can tweak anything on your chart. So SVG is better. So let's take it and download this. Open. Okay, so who hates what kind of groups in Georgia? That's represented by color in this case. So LGBTQ community, gay people, Roma, Chinese, United National Movements, politicians, and so on. So let's say you can, I don't know, you can transform this description into saying that, let's say you represent some kind of group or minority or sexual minority or political party or something. Is it advisable to go to Georgia or something like that? You can incorporate that information into something that might be more relevant to something else that you want to persuade people into something. I don't know. Okay, so you can, if you use other data or other variables, you can do the same for different kind of data. Has anyone done anything interesting? Yeah. Backbenchers. On the backbenchers, did you do anything? Okay, actually, you can upload that visualization to the folder that I shared, and we can see it. And don't be shy; it's just a very basic practice. And we can finish it soon. Sorry. In general, yes, because most of the time we are trying to refine our charts. It's always better. That's also in practice when people, for example, if you make visualizations and you you have to share that visualization with the journalists, for example, so they can publish it. Most of the time they have graphic designer and they use either those SVG or PDF files. So most of the time you have to save in that format. They're the only ones that give you the possibility to change them in a very detailed way. Once you upload it, tell me so I can open it. Anyone else did anything? Or do you want help? Mm-hmm. Mhm. If I work, I had yes, I did participate in one research. They actually, it's Uznadze Institute is located in Ilia State University, Psychology Institute. So they did this research, like a psychological reaction to the pandemic, like stress, how worried they are, what kind of coping strategies they have, and they wanted these reports, like a popular reports, and I did visualizations for them. Yes, I do. Where's the file? Sorry, did you upload it in this data folder? Okay, hold on. You should go to this. Okay. Okay. We can describe what it did. I don't know how to let you access that folder to upload something, to be honest. Share. Mm-hmm. Okay, that's true. Can you try now? Okay, I can show you actually before until you upload that file. What I mean when you have to save it in SVG. So once you download SVG, this is how you can use it in graphical software. We have very small screen. But anyway, so you see that I can interact with each element on my charts. So I can, for example, select just a single text and change the fonts. If I go here, I can do that. We can't see it here, but anyway. So that's why you have to use either PDF or SVG. You cannot do it if you output it into PNG or JPEG. Yes, you can do anything, whatever you want. In PowerPoints. Okay, so if it's SVG, you can do that. Okay. And you can change the color, but you shouldn't. But okay, let's see the file. Okay, so you chose spider charts. Yes, that's a good way to. So if you have multi-dimensional data, which means you have many variables and you want to represent those variables into a single chart, this is a good way. Maybe it's not a good way because it's a bit problematic in terms of how we can perceive this chart. But we have. So what you have done is you have taken PT, NBNs, excludes, and you have faceted this data by what did you choose? By group. Sorry? No, so this is called faceting. If you have okay, if you have different categories, you can cluster the data, which means you can see the same information for different groups in your data. In this case, we have actual groups of into a society, and we can see on these 3 dimensions, on PT, envy, and excludes, what is their score in our data. So we have different one here, we have different here, and so on. This means that we have for who are these people? I can see it. Poor people, yes. Okay. So poor people, they have a lot of PT for poor people in Georgia. They have also high rate of exclusion. So they are excluded from the society, but people do not envy them. That is what this data tells us. So I don't know, can you say something, can you use it in your pitch if you want to persuade someone about any topic related to how people think about different groups in Georgia? Would you say something that you would use this information in your pitch in any way? That's not yours. So whose is this? This one, yours. So can you say anything like, I don't know. This charts. Okay, so you have okay, it's good you mentioned that it's not understandable on the first sight. As a general rule, the chart doesn't have to be very clear. Just you do not have to perceive everything what is on the charts. That's not the objective, your purpose when you're making visualizations. Sometimes that might be as the stripes of the global average temperature. You might want to just show it, then people should be able to understand the chart in seconds. But in most of the cases, you gave them a lot of information. It takes time to understand the chart, and that's okay. That is how it should be. And very often we as well, do you remember we use this municipality data of people, or how people, whether they stayed at home or not? We use the same methods. We faceted the data by the municipalities. This is the same. In principle, this is the same one. Okay, let's see this second one. We can finish our workshop. Okay. So can we give them the microphone?
Yeah, I was saying that it doesn't contain a lot of information because we just used groups and competences. So it just shows that information, nothing else.
Okay, this is it's called the radial charts. So this is basically, it's almost like a bar chart, but on polar axis. Did you have any insights? Did this tell you anything interesting?
With this information, no. We were just trying different things, and this is
okay. So this competence means how people think about that group, how competent they are.
Yeah, but
so we see that Jews are viewed as most competent people in society.
Yeah, for me, it just lacks the information. It doesn't say much about those groups. So I will not present that graph or something for the audience, to the audience.
But actually, in reality, this is a very good research.
Really?
Yes, this is taken from academic paper. This is a very good research. So this is it's a bit different methodology. It's you ask respondents what people in your society think about those groups. You do not ask them directly, what do you think about Jews, for example, because people then might have some kind of self-censorship because they are pro-social and they will lie. They want to tell that I think that they are bad people. So it more or less represents what people think about different groups in society. So it's also not surprising that people think that Georgians are very competent people after the Jews. Then businessmen, priests, rich, and so on. Yes, that in terms of analysis, that gives you lots of information, like what people think are competence, and whether what kind of do they create cluster. That's a good one. If you had used, for example, not the bubble chart, but it's called P-swamp charts. Let me see. This is good one. Yeah, P-swamp plots. And let's take, hold on. Competence. This is more, probably this is better charts to represent the data. So let's see, we have different groups. We have competence. Let's size be also competence. So if you go down, you can see what kind of groups are perceived as most competent. Hold on. Those are Jews, priests, rich people, businessmen, Georgians, liberals, Orthodox Christians. So this is a good way to, so you can answer the question, who people think are most competent in their society. Once you have the kind of insight and description, you can, then I don't know what you might be doing, what you might be pitching for, but you can use that information but transform it into some more catchy phrase so you can influence other people. I don't know what might be in this scenario, but that's the point. That was the point of this workshop. So that was what I want to say.